Example 2, graph shows the behavior of a ball a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval. So one thing we're looking at is whether the function's increasing, decreasing, or constant. And so from the picture we can see they've split it up into two intervals. Interval 1, if you'll notice, the graph's going up, and so it would be increasing on that interval. And interval 2, it starts coming down, so it's decreasing on that interval. So we could say something about, a little more specifically, that the height is increasing in interval 1, and the height is increasing in, height is decreasing during interval 2. On the try it graph shows the behavior of Skyla skateboarding at the skateboard park. In which intervals is the function increasing, decreasing, and constant? So if we just look at the different parts of the graph here, so we could just make a table so we can look at each of these. You can see in this first interval, graph is coming down. It's got a negative slope here. So that would be decreasing, interval 1. Interval 2, it's kind of just going straight across here. So that would be constant for interval 2. Interval 3, it's coming back up here. So interval 3 would be increasing. And then interval 4, it starts going back down again. And so that would be decreasing for interval 4. And, you know, you could think about a story of what's happening here. They didn't ask us to do this, but, you know, this is the distance from the above the ground and over time. So, you know, they're starting out maybe at the top of this ramp, this half pipe, whatever, and then they come down, and then they go just on ground level, and then they start going up the second ramp or something, and then they get to the top of that, and then it looks like interval 4 maybe just starting to go back down another ramp. So on page 191, if we look at example 3, again talking about intervals of increase and decrease, they're asking which intervals the function is increasing, decreasing, or constant. So increasing is where we have a positive slope, where it's going up. Decreasing is where it's going down, where we have a negative slope. And constant is where it stays the same. So that would be where it's got a horizontal line. So you can see, like the book's showing us here, intervals 1 and 3, it's increasing. It's constant on intervals 2 and 4. Notice those are just horizontal lines. And then it's decreasing on interval 5. So interval 5, you can see that's going down. So that's decreasing on that interval. So it's really just a matter of looking at what direction the line's going. The try it says write a scenario the graph could represent. There's lots of different options. One option the book gives is that somebody's riding their bike from their house, and then they take a break, and then they ride further from their house, and then they stop to eat, and then they ride home. Okay. Again, notice this is distance. If that was the case, maybe distance from home would be a better label there, if that was actually what was happening. Otherwise, if it's just a distance, your distance is always going to either, you know, how far you've gone, it's either always going to stay the same or going to keep going up. It's not going to come back down unless, you know, like I said, that was a distance from home rather than just a distance. So on page 192, let's look at the do you know how number 4. And it asks, what does the graph of the function at each interval represent? So you might say, well, I don't really know what's happening here. Basically, all we're doing is thinking about what our X and Y are representing, and then whether this is increasing or decreasing is the main, those are the main things we're looking at. So here would be an example of how we could answer this question. We could say the function is increasing in interval 1, which means that as time goes by the height is increasing. It is decreasing in interval 2, so as time goes by the height is decreasing. Okay, and again, that's just, again, kind of looking at our labels on the x-axis and y-axis to kind of give a little bit more description than just saying increasing interval 1, decreasing interval 2. So if we look at number 5, it asks in which intervals is the function increasing, decreasing, or constant. So we could just kind of make a table here and look at increasing, decreasing, and constant. And then just list the intervals that it's doing those next to it. Okay, so interval 1, it's going straight across, so that would be constant. Okay, we could label this, I guess, interval or intervals. Interval 2, it's going down, so that would be decreasing. Interval 3, it's coming back up, so that would be increasing. Interval 4, it's also coming back up some more, so it's increasing. It's not a straight line here, but that's okay. It is still going up somehow, so increasing, we would say. Interval 5 is going straight across, staying the same again, so that would be constant. Interval 6 starts to come back down again, so that would be decreasing. If we go to workbook page 47, we'll look at a few problems here, starting with number 1. So number 1 says use the graph to complete the statements. So basically, kind of backwards a little bit from what we did last time. Instead of telling what intervals it's doing different things, they've got them grouped here, and then we're just going to tell for each one whether they're decreasing, increasing, or constant. So if you look at the first box here, intervals 2 and 5. So both of those intervals on 2 and 5, we can see those are both going down, and so those are decreasing. The next box we've got is with intervals 1, 4, and 7. So we'll look at 1, 4, and 7. So those are going up, so those would be increasing. And then if we look at the last one, we've got intervals 3 and 6. So 3 and 6. Those are going straight across, so those would be constant. Look at number 2. The graph below shows the temperature inside a freezer and a science lab. Is the function increasing, decreasing, or constant? So for this one, we see that horizontal line again means it is constant. So we could say the temperature is constant because it is staying the same over time. So number 3. Demi went for a run in the park. The graph shows her speed during the run. Describe the graph when the function is decreasing, and then in how many intervals is the function decreasing. So to describe that for part A, we could say that if it's decreasing, then it's going down and the line has a negative slope. Part B asks, in how many intervals is the function decreasing? So if we just go back and look at our graph, look for places where the graph's coming down and it's got the negative slope. And it looks like we have 2 instances of that. So 2 intervals where the function is decreasing. Number 8, they're asking which graph matches this description. So function is constant in interval 1, increasing interval 2, decreasing interval 3, increasing in interval 4. So just go through the process here. Constant in interval 1. If we look at the graphs here, the only graphs that are constant for interval 1 would be graphs B and D. So that's already got it narrowed down. It's not going to be A or C over here. Increasing in interval 2, both of those have that. Decreasing interval 3, both have that. And increasing interval 4. So B is the winner here. That's the only one that matches. And again, we did have to go all the way to the last description there in order to figure out that the answer would be choice B. So this gives you an idea of how to work with intervals of increase and decrease, and also intervals of constant.